So I will not speak long about this, but as some of you do know, we sit across a number of sectors in the Midwest Hub. We've got transportation and automotive, manufacturing, agriculture, food, energy, water, food production, and lots of other industry where the management of supply chain, particularly in the Midwest and globally, where we need to think about applications, data science and big data applications to make sure that our supply chains are resilient in the face of all sorts of man-made and non-man-made events. I've been thinking about this for a long time and was lucky enough to meet a couple of people that this is their space and expertise, and they have very graciously helped me put together a panel. And they actually put together the panel. I sort of stood back and let that happen, so I'm grateful. So first of all, I'd like to introduce the two co-chairs, and Ravi Nath is going to moderate for us. He's the chair of the Business Intelligence and Analytics Department in the College of Business here at Creighton University, and Amy Kircher is the director of Food Protection and Defense Institute, a great institute up at the University of Minnesota. We are very pleased to have them, and we have from the industry side, Vishal Singh, who's going to open up from Quantified Ag, and they'll tell you a little bit more about themselves when they come up, and then Danielle Richardson from ConAgra. So welcome. Thank you.
Thanks, Melissa. Good afternoon. As Melissa said, my name is Ravi Nath. I work in the College of Business here at Creighton, not too far from here. And I don't want to take too much of your time, but we will start with Mr. Vishal Singh, who is the CEO of Quantified Ag. And so the way I would like the panel to run is about each panelist speaks for about 10 minutes each. That's about 30 minutes, and we will leave the last 25 to 30 minutes for question and answer session. So Vishal.
Thank you. Thank you for having me speak here. So I grew up in a small town here in Nebraska. I went to high school in a little town called Pleasanton, which is a town of 450 people north of Kearney. And when I was growing up, I made up my mind about one thing, and that was that I would never wanted to work in agriculture. The reason why I didn't want to work in agriculture was because most of my friends grew up on farms or ag families, and every day I would hear them complain about how they had to wake up early and do chores and yada, yada, yada. So I had no desire to work in agriculture. And at that time, I had never made the connection that my interests in design and technology could ever lead to a career in agriculture. Now, fast forward to where I am today. I am the CEO of a company called Quantified Ag. We're a precision livestock analytics company based in Lincoln, Nebraska, on the Innovation Campus. So if you haven't ever had a chance to visit Innovation Campus, if you're ever there, come look me up. So a little bit about what we do. So if you're not familiar with the beef industry, the vast majority of the beef cattle in the United States make their way through a feedlot at some point or another. And at these feedlots, there's this job of a pen writer. I think growing up, some of my friends did this job and whined and complained about it. So what these people do is they go out every day and they have to visually scan hundreds, if not thousands of animals, trying to pick out the sick ones. And a lot of those sick animals are missed. And it's not because the pen writers are lazy or that they're bad at their jobs. The basic problem is that there's a conflict of interest. The animals, because of their predatory response, hide their symptoms from humans. And humans are standing there trying to pick out the symptoms. It doesn't work. So that's the problem that we solve. What we do is we monitor the cattle 24/7, and we're able to identify the sick ones so the pen writers can know exactly which ones to focus on. So just a quick overview of what the overall problem is. In the United States, we've got roughly 23 million head of cattle that are in feedlots. Out of all those cattle, about 21% or 1 out of every 5 develop some symptoms of illness. So there's a lot of cattle that are getting sick out there. And as research has shown, pen writers at best are about 60% accurate. And when they are detecting the illness, it's very late into the process. So what we did was we developed a smart ear tag. This ear tag is attached to the ear, well, of course it's attached to the ear, it's the ear tag of the animal. And what we do is we collect basic biometric data like ear canal temperature, and we also collect behavioral patterns, overall activity, head movements, all that stuff added in. And what happens is the ear tag collects this data, transmits it to a central base station. The central base station dumps it to our cloud servers, and that's where we process all this data. We utilize machine learning and other techniques to process through it. And the goal for us is simple. We just want to be able to detect the illness early and more accurately than a pen writer. So far in our clinical trials, we've found that we're doing this very successfully. In clinical trials that were run this summer, our system had anywhere from 85% to 87% accuracy, which is way better than a pen writer. And the most amazing thing that we found was that our system typically picked out illness a lot of times up to a week before pen writers could, and even veterinary observation could. And so we feel like it's working, and it's working rather well. Beyond the basic data gathering capabilities of it, you can't just provide data because that's not very useful. You have to provide useful information. And our customer base is the feedlot managers of these large feedlot operations. And so we provide them with a fully built out animal health dashboard. And this dashboard can show them a lot of information beyond just which animals are getting sick. It can show them patterns of heightened activity around feeding times. It can show them how the animals are responding to weather patterns, a variety of different things that they can get out of this whole system. When we actually get into the cloud platform that we've built, essentially what it does is it allows the cattle producers to do drill downs into the data for their animals. They can start out on a large scale and look at what's going on in their entire herd, drill down to specific pen numbers or pens of animals or lots of animals, and then even drill down to individual animals and see what's going on at that level. And that's really the goal of the entire system, is to, one, detect outliers, and two, to make it very quick and easy for the feedlot managers to drill down into their operations. Just a little quick background about how we store the data. We've got cloud storage. It also makes it so that the types of data that we're gathering and where we're headed as a country, I think where we'll converge eventually also will be on this whole issue of traceability for beef. That's going to be a growing issue, I think, in our country. And just another quick point on this slide. While I said that we've built our system for the feedlots, we've actually found that a lot of interest comes to us from beyond feedlots. A lot of the cow-calf operations, ranchers, even dairies are quite interested. But our core focus is the feedlots. Beyond the feedlots, there's a lot of interest in this type of data in the rest of the industry, anywhere from the big restaurant chains to the grocery chains, and so on and so forth. Just having access to knowing, what's going on in the supply chain. And I feel that this is truly a win-win situation. Not only a win for the cattle producers because their operations are more efficient and more profitable. I think it's a win for even the animals because they don't have to suffer unnecessarily through illness. And I think it's a win for all of us, the food consumers, because we have a better food supply. So that's just a quick overview of what my company does. Next time, you're driving down the road and, here in Nebraska, it happens very often. You might run into, see a distant herd of cattle as you're driving down the interstate or the highway, just remember how difficult it is to keep those animals healthy, and just think about how applications of data and analytics can improve that whole process and what we're doing here. Thank you.
Good afternoon. I'm Amy Kircher. I'm at the Food Protection and Defense Institute. We're an institute that was created after 9/11 to look at protecting the food supply from any adversity or disruption. So up front, there are a few things you should know.
We have 4 objectives. First, we'll talk about the
We'll
complexity.
skip that. I don't know why that is talking. I'll just tell you about that. I'm an epidemiologist. I am not a data provider. I am not a necessarily, I don't come from data engineering or computer science. I come from a field that worries about making sure all people are well and taken care of. Currently, I work on pandemics, but I also work in food. So I try to embrace interdisciplinary activities. So to me, this is a honeypot. When I talk to some of my computer friends, this is a honeypot. It's a decoy computer to catch hackers. Let me just tell you, I spent 20 minutes in a conversation. I was talking about the one on the left. They were talking about the one on the right. It's very difficult. So know your subject, and maybe if it's not making sense, ask more questions. And I really believe in sense making. So in the back end, how do we take big data and use it in a meaningful way so that we can answer a question? So let's talk about our global food system and how complex it is. I like cheeseburgers. So there's my favorite. Depending on the recipe, you can guess how many ingredients are. I'm gonna make you play the game today. Are you ready? Okay. How many ingredients are in your bun? Tell your neighbor. How many? How about the burger? Cheese? Woo! I think this surprises everyone. And just wait till you deep fry those suckers. And I don't know about you all, but I surely like ketchup and mustard. How many counted while we were going through? 84. That's 84 different supply chains I have to protect for you to eat your cheeseburger, and 84 potential disruptions that could come from this. Now, if we look at each of those ingredients separately, and this is just data I have on importation into the United States, for 6 of those ingredients, look, we source things from around the world. For those of you who say, oh, I just eat locally, I think you're lying. And I will have this debate during cocktails, because we hardly can eat, especially here in the Midwest, off of a local palate or a local food source. If you put pepper on it, you are not eating local. So when we think about disruptions, we have to think about several things. Here are the 5 we think about at the Institute: accidents in Mother Nature, and then the bottom 3 are intentional. Now that's why our Institute was created. However, we've expanded and look at everything, but sabotage, terrorism, and then economically motivated adulteration or food fraud. I'm gonna go fast, so buckle in. The problem that we need to solve is that typically we find food system disruption when people are sick. That's that X on an epi chart, cases over time. That is not okay. We have to shift that to the left and pick it up earlier in the event so people don't get sick or we have morbidity and mortality. I'm going to argue that with big data analysis and sense making, we can even shift that further and we can predict when disruption will happen. Here's an example. So we had industrial dyes being added into chili powder. That first black dot is where the adulteration happened. It then was sold from an India-based company to a UK-based company. You'll see it go into a central node where it was then redistributed into multiple products and ended up in over 4,000 final food products. That's a lot of recalling. So to get to that predictive analytics, we need to really understand what drives disruption in our food system, whether it's natural or it's intentional. And so here are all the factors that we start to look at and where we start to grab data and try to put it together in meaningful algorithms to say, because A plus B equals C and it's greater than 3, we should alarm because something is creating disruption in our food system. So what is my question? My question to all of you, and I seek your support, is how do we protect our food system? We've referred to this as food formatics. It's not sticking. I could use help with another name. But really, these are the things that we're trying to do, is create methods and tools to process both diverse and unstructured data to solve our challenges in food safety, that's natural, food security, that's not having enough food, or food defense, that's bad guys entering our food system. And we have examples of how we can do this. Our first proof of concept was in Japan. Of course, they had the horrific sort of triple event where we had an earthquake, a tsunami, and then resulted into a radiological release. Once we're able to start piecing that data together, we can add actions. And in that particular situation, we were able to support governments and companies by saying, look at the long-term contamination of seafood, literally the food chain in the ocean. When bigger fish eat smaller fish, that's going to take a while. So the ban was originally 3 months. It needed to be extended longer. And we were finding tuna 15 months later with radiological signals. Radiation in California dairies, we knew that would come up, so public service announcements would have been appropriate there. And then lastly, we knew the bounce back of the wave post the tsunami took out the Chilean sea scallop beds. That's a 2-year harvest cycle. So if anyone is trying to import sea scallops into the US for 2 years, they're probably lying. And we know historically what people do is punch round circles out of white fish and they sell them to you as scallops. So who cares? We really focus in on who are our stakeholders. Well, it's lovely to be at the University of Minnesota and cheer for the Golden Gophers. We're not big fans of pet projects that don't actually advance our discipline. And so we had to think really hard about who's going to use this data and what decisions they're going to make from it. We create user personas for each of the products that we create or the analysis we do. So here's just an example of a food company. We give these personas names, responsibilities, pain points, and then work to operationalize how we're looking at big data and doing our analysis to meet whatever this persona's name is. Again, we've talked about it a lot today. We need to find data that matters. Here's my epic fail. We looked at the Twitter fire hose for people who are sick. Let me just say, I found a lot of this in there because when you think about vomit and barf and poop, people use that as slang. So none of these people were actually sick. And if you eat rainbows and poop butterflies, that's not really an illness that's diagnosable. So what are some of the data we can use? One is pricing. This is the melamine scandal in 2006. You can see where pricing is highly variable. However, China was coming in very low with pricing. What we came to find out later is melamine was going into the dairy products. We could look at refusals to country, refusals of food coming into countries. This is looking at refusal data, and we've pulled out all the codes where administratively we've said, we are refusing this food because somebody put a poisonous substance in it. We now, using a taxonomy, can collect that all around the world, the EU, Japan, Australia, and the US. We can look at environmental conditions. It's really hard to know if we have a problem looking at forecasting data because I don't know if tomorrow's rain really is going to cause a flood. So how do we put data together to do precipitation analysis or growing analysis to know if we might have low yield? And then the #1 stolen truck in 2015 in the United States is a food truck. not an electronics truck. This is a heat map of where those trucks are stolen. So for a company, this is super important information to know so they can A, reroute, or they can change the stops of their drivers. So when we think about analytics and decision-making, we refer to it as sense-making. We're making sense of that data. But it's not only, as we've said earlier today, AI or NLP, it's people and technology. And so what we've done is to bring these diverse data sets together for food and looking at disruption. We've created an ontology. Most of you know what that is, so I won't spend much time on it. Ours has a quintuplet on it, so it's place, time, food, adulteration, and effect. So for every piece of data that passes through our system, we can code it. And as we code it, we can add additional fields and information, news stories, maybe reports from the WHO or laboratory tests, and create a case that starts to illuminate itself and gives us an understanding of severity of what we're dealing with. So when we work at the speed of disruption, we realized really quickly we needed to create a capability at the University of Minnesota and our institute to be able to collect all of this data, clean it and organize it, and then run our algorithms on it, and then get it back to the people who need it. That might be an analyst workstation, or it might be an API back to that company so they can use it with the other proprietary data they have. We lovingly refer to it as our food data lake. So now we have 10,001 lakes in Minnesota. And this is some of the technology that we use to move that data around. So we have several means of collecting data and platforms that we had already created, as have others, about doing analytics on food. We've created some original data streams of our own, and then these are just some of the tools we use to put that together. I can talk more about those later as well. So let me give you an example really quickly. Two examples. One is supply chain variability. Most companies know who they bought from and who they sold to. Now, with few exceptions of those that are going to be in the room after me. We need to understand that whole supply chain. This is breaded shrimp that you may have purchased at a retailer. It's coming out of Southeast Asia. If I don't understand my whole supply chain, I have a real problem. I can then map that and layer on hazards. So this is the cyclonic probability that's going to be affected. What you don't know here until you drill in is that in Jacksonville, Florida, that's where the breading happens. And if that plant goes down, there'll be no breaded shrimp. That's a big risk and a vulnerability for that particular company. So understanding that is really important. So let's just use one more example. Let's talk about Ebola. We know that it happened based on disaster relief data. It was happening in West Africa and those sites. I also know that the region produces 60 to 70% of the world's cocoa in this area. You can see by the heat map of green and yellow. I've also indicated the ports of where that cocoa is coming out of. You can see on the bottom, based on the information, I can even tell you how much is coming and what the value of that is annually. In this particular situation, we knew that there was movement restriction because of Ebola. It was a mitigation step to decrease the movement of the disease. That also decreases people taking cocoa out of the fields. So we were getting less cocoa out of the fields during this area, either because people were sick or they couldn't move to a location of work. About the same time, cocoa futures went through the roof. Some of the first responders were Nestle, Dove, Ghirardelli, because this is where they were getting their ingredients from. When prices go up, it's a driver to indicate that counterfeiters will try to get in the market with fake food. We can watch for those prices, either the quantities, new companies coming into our country. So this is a QSUM methodology. I'm looking right now at cocoa beans that are whole and raw. Anytime that signal trips the threshold, I know that it's anomalous to a historical pattern. I should investigate that signal to noise. In the data set that we've pulled together from multiple places, I can also say, okay, so we have maybe less yield coming out of the fields, the price has gone high. Have people messed with cocoa in the past? Well, sure enough, we can get into that data, and you can see here that historically people have. They have messed with your cocoa, they have put arrowroot in it, grain flours, cocoa husks, and they have put dirt into your cocoa, all to make money. Cocoa's also been refused, and so here are all the locations in this particular time frame where we've had refusal of cocoa into someone's port. From this information, we can share it with other people working within the industry or those that might be responding. So there's a discussion board up on this particular platform. And finally, that gets us to a call to action. By layering this data in a meaningful way or making sense of it, we know that there are drivers currently happening with the Ebola situation where adulterators will take advantage and try to make money. So what should we do? One, we should monitor the import quantities of cocoa coming in. If you don't know, we inspect about 1% of food coming in this country. If we can target problems, we can inspect more. We can monitor new suppliers. Often people who are doing food fraud will introduce new companies and they'll come into the market and they'll be unknown. We can track the supplier pricing. If someone's really low and undercutting everyone else, there may be dirt in that cocoa. And then finally, we can inspect the cocoa at a higher rate than we normally do. That's us. We protect your food from farm to fork and udder to butter.
So hello, everybody. I'm Danielle Richardson. I work for Conagra Brands. And for those of you who don't know what Conagra Brands is we make food. And you've probably heard of some of the brands that we make. We make things like Peter Pan peanut butter, Wesson oil, Pam cooking spray, Marie Callender's banquet pot pies, David Seed's Slim Jim. I don't know if any of you have ever heard of those products, but they are in about 99% of all American homes. So what I do is I work for Consumer Affairs. I'm the manager of the reporting analysts. So what does that mean? When you produce food, you want to get your consumer feedback. So my team takes all of those contacts. So anytime a consumer calls us, they can contact us to let us know what feedback they have on our products. So they can call us, they can email us, they can send us a letter, and they can post on social media. So what we do is we take all of those contacts and we figure out if it's a complaint, so I don't like this product, if it's praise, I really love your products, it's a suggestion, I want you to do this with your products, or it's an inquiry, what do I do with this product? We bucket those into categories so that we can analyze the data and look for trends and differences in how our products are performing. So the direct consumer feedback is really important to us to make sure that we understand what are the key dissatisfiers for our foods that we produce for our customers. So when our consumers give us that feedback, my team's able to mine that data on a regular basis to look for differences in the data. We want to understand when there's something wrong with our products, what's right about it, so that way we can give feedback to the business and make sure that we are providing safe quality food to our customers and that it pleases their palates. So some of the ways that we use our data is that we want to make sure that when you're manufacturing a product, if you know you're familiar with manufacturing processes, a lot of times you can't always make it 100% perfect. And when you don't make it 100% perfect, that product can get out to your consumers. And if it's not what they expect, if it's not perfect, they will call you and let you know. So what we do is we look at that data every single day to see, is there something different about the data that we're finding? And when we do, we notify our manufacturing plant to let them know of what's happening with that product. What's the key dissatisfier that this consumer has found that went wrong in your manufacturing process? So they take that information and we expect them to do a root cause analysis and also put in place corrective actions to drive continuous improvement for their products to make sure that we are always providing the best product we can to our consumers. We also use the consumer feedback to update recipes. So when you make a product, that recipe isn't always pleasing to every single consumer. So what we look at for the information of the data is to make sure that if we get consistent negative feedback on a particular recipe, my team provides that information back to the business to let them know, hey, you guys need to take a look at this recipe because we're getting contacts about this is too spicy, I don't like it, it's too bland, it's not what I expected it to be. So that way they can make an informed decision whether or not they need to make a tweak to that recipe. We also use our information and consumer feedback to let our suppliers know that there may have been a failure in their system. So sometimes when a supplier has quality checks in place, sometimes there's things that are undetectable in normal quality checks. What'll happen is that we'll get it through into our food and our consumers can detect that. It can cause an off flavor, an off odor, off texture. whatever the defect is, if our consumers find that, they'll let us know. So what we do is we look at supplier-related issues and defects, and we'll alert our suppliers and also have them do a root cause investigation and a corrective action so that they can continue to provide us product that's within our specifications so that we can provide our consumers with safe, quality food. We also do some predictive analysis. So it's not fancy. We look at what we've seen in the past, and we can also say, if you make a change to this product, we expect your contacts to go to this level for this amount of time. So that way, the business can make an informed decision on if the change to the product is going to be acceptable. So we don't only use just consumer data because we run a call center, we also use the information we collect during a call with our agents on the phone to make sure that they are taking the calls within an appropriate time. They're handling the calls the way we expect them to. They're compensating the consumers with the right amount of coupons. And we use that information to drive quality within and also efficiency within the business so that we're taking the calls to our expectations and also in the right amount of time. We can use that data to drive continuous improvement within our call center so that we can provide the customer, when they call in, a great satisfactory experience. So we use a couple different ways to analyze the data. Some of it we consider high tech. You guys would probably think, that's nothing. But one of the things we do is we use tools to monitor social media. We use a third-party tool that looks at social media. It monitors public feeds every 15 minutes and returns back information that looks for certain keywords related to our food, so food safety issues. So if someone says, made me sick with one of our brand names, it'll pull that information in and flag us to go take a look at that contact and dig into it to see if we need to take action and engage that consumer. We also do some kind of low-tech analysis on our regular contacts. So when people call us, we look at it through pivot tables. And so that's how we do most of our data analysis. We are trying to use some more statistical methods to do analysis. So we've engaged some of our team of statisticians to look at what are the normal trends of a product, because when you have a food product, you have normal trends of complaints going up and down throughout the season. So pie eating season, you will see a spike in complaints because more people are eating pies, or if it's hot dog season, there'll be more people complaining about that. So when these reports will look at the normal variability of a product, and when complaints exceed the normal variability, the reports flag us to go look into this in greater detail to figure out what's going on. So we don't just rely on reports to tell us what to do. Those reports just give us guidance on what are some key areas to look at. And one thing that we do is I have a team of analysts so that will go in and look at that information. So we don't just rely on the reports, we also use people as part of the equation for analysis. One of the things we have to be careful about is when we do report out to the business, we have to be careful and pick and choose what we report out, because we can't report on everything. We can't react on every single data point that comes to us. So we have to make sure that we're careful about what we report out and that it's the most critical things for the business to go work on. Some of the struggles that we have with data, especially with social media data, because there's so much of it, is making sure we have accurate data. If you don't have accurate, complete data, you can make the wrong conclusions or assumptions about it, and it can totally throw you off course. Social media, there's a lot of things called rabbit holes. Oh, I should actually advance the slide. I'm sorry. That'll make more sense. So some of the struggles that we have with social media is just the immense amount of data and information out there. We call it rabbit holes. I don't know if you guys are familiar with that or not, but those are those bright, shiny objects that get you distracted from the real information. Social media posts can be interesting and entertaining, but most of the data is not very useful. We found that social media, there's a whole lot of people who have a whole lot of nothing to say. And trying to weed through that is very, very painful. The other thing that we have to take into account is the majority of our data customers are not data scientists. They're not interested in giant Excel spreadsheets. They're not interested in the large amount of information that we can provide. So we have to be very careful, and we have to take that big amount of information and we have to make it usable for our customers. We have to tell that story, and that's a very hard thing to do sometimes. And that is a skill that is hard to come across. It's not always a trainable skill. So being able to tell that story is extremely critical for being an analyst and working with people who aren't familiar with that information. So some of the other things that we struggle with is text analysis and sentiment. So one takeaway is if you guys can figure out how to do sentiment analysis, so when determining whether it's positive, negative, or neutral comments on social media, that's your million-dollar idea. Because text analysis right now can't do sarcasm, and we struggle with getting feedback back that says it's a positive comment when really it was, your product's awesome, I puked for 4 hours afterwards, I ate it. That's considered a good or positive comment? Really not. And then just making sure we have real people to interpret the data and making sure we tell that story. So we're trying to get from being a data number-driven organization to being more of a pictograph or like a picture tells the story of what we're trying to tell them, because that comes across a lot better than a whole bunch of data or a whole bunch of numbers on a spreadsheet. Thank you.
Thank you, panelists. I'm going to open it up for questions. If you have any questions, please, this is the time to ask the panelists any kind of questions pertaining to the supply chain in the food industry.
I have a question for Amy. I wanted to know about the difference between fakery and safety, because it seems that your data collection will pick up a lot of instances that are about people being tricked. So eating whitefish instead of scallops, for example. But it's not actually a safety issue, because they don't know, if they think they ate scallops and they're happy, then there's not actually a safety issue. So is there a way that you parse your data for, for example, the dirt in the cocoa? Probably it's actually not going to hurt you to eat some dirt in your cocoa. So how do you figure out how to message the data so that people get alarmed when they need to, and it's sort of behind the scenes when they don't?
Both. So that's a great question, just to repeat it. How do you tell from fake things that are going to hurt you and fake things that aren't going to hurt you? And I have a very funny Dr. Oz story later for the bar. So the real concern is just, where's there disruption in the system? So what is fake? So start with what is fake. So some people are just appalled that they've been taken, right? But if you put water in lemon juice, it's not really a public health issue. The horse meat scandal in the UK, also a great example where eating ground horse isn't going to harm you, but people, that is just not a preference to eat horse when you think it's ground beef. And so first we have to find first we say, let's find the disruption, what's counterfeit or fake, and then you have to put it into 2 buckets, maybe 3 buckets. One, is this something that has to be notified that is not as labeled because it's a fraudulent product? And then of those fraudulent products, is it going to create public health harm? And then when we go to public health harm, there's even a split there, a bifurcation in that. Is it typical food safety issues where we see it a lot, it's maybe salmonella, or is it actual food defense where somebody is intentionally doing something to harm us? So for instance, we do have a current case in Germany that just came up this past week where someone is lacing baby food with a poisonous substance because they're trying to create harm. So first, where's the disruption? And then secondly, how do you characterize one or the other? It really is human behavior, whether how upset they get. Some people are equally upset by public health harm as they are about having spent money on fake food.
Yes. So in the past, we've dealt with economic adulteration with ConAgra. We've dealt with spice economic adulteration, where peanuts were actually used in some of the spice blends that we had. So we had to make a decision as to whether or not to recall product because it's an allergenic concern that's undeclared on the label. So it can definitely be a huge risk for plants and manufacturing.
Huge cost to recall.
Other questions? Vishal, I have a question for you. How do you kind of protect the privacy of the cattle owners? Because cattle won't be interested in that, but the cattle owners might be. That they don't want their proprietary information going out, and they're heard, higher percentage of them are sick versus somebody else. So how do you deal with those kind of issues?
Sure, and that's a great question. And you're exactly right. For these different feedlots, It's a very competitive environment for them. I'll tell you this way. Early on, when I was first kind of doing my customer development to figure out what's the problem and how should I go about solving it, I very naively used to just cold call feedlot managers, and I would, somewhere in the conversation, I would ask them, well, what's your death loss like? And obviously the answer I kept getting was, oh, it's not that bad. It's perfectly fine. Because nobody wants to share that kind of information. It's a competitive advantage. It's a huge competitive advantage. So the way we treat that is that we treat each feedlot's data as their own data. They control who gets access to it. So if a feedlot manager, has our system in place, they can decide, okay, which veterinarian they want to give access to, which nutritionist they want to give access to it. Do they want to give access to their, lender who provides their note? Those are decisions that the actual customer makes rather than us making the decision for them.
No. I know that all of you kind of alluded to the fact, how do you present that information to the final consumer of the information? Vishal, you talked about, well, it's going to go to feedlot owners, so we got to make sure they understand it. I think you talked about, Danielle, you talked about that we got to make sure that the people who get the information don't get too much of it or not too little, just the right amount. What is that right amount? How do you go about the process of knowing what is the right amount of information? What format is it going to be?
It's really a struggle to figure out how much is too much. I know when you ask people, what do you want to see in your report? They're like, well, I don't know. So it's really just figuring out, it's kind of trial and error. What works best? Pictures work best in our case. So people don't want to see a line of numbers saying, here's the complaint rate going up or down. They want to see a picture. They want to see a line telling me, so at a quick glance I can tell exactly what's happening with that product. So it's really been through trial and error, and then just feedback from people, what they want. We found that sometimes the higher up you go in the food chain, they don't want the details. The lower down, they have to have those details to be able to drive the continuous improvement. So you really have to customize your reports for your audience and what the people need and what their end result is going to be.
From the perspective of Homeland Security, I think it's really been a challenge of, we are very fortunate in this country to have a good food safety system. And when you start talking to people about, food fraud or economically motivated, you'll hear the, 60-minute scandals of olive oil. But there are other incidents where it is maybe more concerning, like if terrorists are trying to start thinking about introducing a biological agent into our food that is harmful, how do you communicate that to the public? Or how do you communicate the behavior you want humans to take without scaring them that it's okay to eat food in the U.S.? And I think that has been a big challenge with many Homeland Security things. But, the one thing about food is you can't opt out of it. If there's a threat to another infrastructure in this country, you may choose perhaps not to fly. You can't choose not to eat, or at least not long. So how do we balance that we have safe food and warn people about being careful about buying behaviors and how they consume?
Michelle.
So your question was about the sensitivity and how sensitive is too sensitive, right?
Right. How to present it to the users.
So we ran into this exact problem. Very early on, one of the things that we ran into was our system, we put it in place, and a lot of times, remember I told you that right now there's about, roughly 21% of all these animals that get symptoms of illness? Well, early on, when we put the system in, we were seeing that the system was flagging about sometimes as much as 40% of the animals. And for the pen writers, it was kind of like walking down a block with lots of car alarms going off. Where do they pay attention to if there's that many alerts going out? Well, at first we thought, well, should we maybe try to scale our system back so that way it matches roughly that 21% of alerts? But the more we thought about it, that's not really effective. We're kind of defeating the whole purpose of our system, detecting the illness early. And so what we did instead was we actually, for these early users, we actually started doing we just started doing deep nasal swabs of the animals and running those results back to a vet diagnostic lab to prove to them that even though our system was flagging more animals than they're used to pulling on their own, that they are indeed sick. And look, here's the actual illnesses that they have. And that seemed to be the right approach, and that's proven it out for us.
Okay, great. Question?
Very nice panel. I heard this concept at a different conference, and the idea was that because we can track our food from the udder to the butter, to use that frame, when we connect that to health outcomes, one of the challenges, and I'm coming from a public health background now, is that will ConAgra be changing what it's putting into the food and how it's growing and its practices? And would the beef have to be, meet the supply and demand because the consumer is now going to know what's in there? And this is in the context of Internet of Things, where there are refrigerators now that can scan the milk and order it for you if you're running low, but they can also know the ingredients that are in that milk. Or that brand of milk, or where it came from. So I'm wondering if the panelists can address how one would balance that. Do we really want to know everything we want to know about the food that we eat in the context of health? Thank you.
I'll start. I think that's a great question, and we probably all have opinion on that. So based on the data that we look at, we can absolutely see that consumers drive changes. They drive changes in flavor and all those things you would expect. But they also drive the ways we're producing and providing food. So I think Bumblebee is a great example where they saw that their customers wanted to know the boats where their tuna came from. So if you scan a can of Bumblebee now, it will tell you where it came from, and they quickly got ahead of that trend. I think the other thing we're seeing is that there are medical preferences for food, or medical restrictions perhaps, or even dietary preference. The increase of gluten-free you see in your grocer now is incredible. It's not because there's a medical need for that, but there are dietary preferences for that. All of that is shifting what we produce and how we produce food. I think as we continue to evolve as a population and from a public health standpoint, start to tackle perhaps obesity challenges, we're going to see the market or the food industry adapt to that. I think soda is a beautiful example. And if you look at some of the people who track and trend food, one of the biggest changes that they've seen over the past couple decades is the decrease in soda because moms are making a change. And so you're starting to see, the big beverage providers don't just make soda, they make orange juice and water, and they're diversifying their portfolio because the demands either coming from preference or public health are changing that.
Yeah, so in dealing with the consumers, what we try to do is we try to be, as a company, more transparent because consumers want to know why you're using something in there. What purpose does this ingredient have in your product? So we try to let them know as much as possible why we're using this, and we're also trying to drive toward clean labels so we don't have as many artificial ingredients in our products. The other thing that we have to combat with consumers is misinformation on the internet. So we have a lot of requests for gluten-free. That's one of our big contacts. Is this product gluten-free? The other thing is people want to know GMOs. GMOs is the big buzzword right now. So we have to combat, information for people saying, take GMOs out, to the other end of the scale saying, I'm allergic to GMOs, can you stop putting it in your product? So they really don't understand what they're asking for. So it's trying to educate the consumers as well as make products to please the consumers.
Yeah, I think you both answered that very well. I think it's the consumers that drive it. In the industry I work in the beef industry, they've tried traceability, and I think the question always comes back to what is traceability. In our industry, they've tried it before, but the problem was they tried it from the perspective of traceability for government agencies, not for what consumers want. in our industry, the traceability I tried before was all about, well, which location did this beef come from? Most consumers don't really care about where their beef actually came from. They care about how healthy was it. And so I think the definition of traceability is getting redefined a little bit. And as long as it can meet, that redefinition can meet the consumer demand, I think that's probably the critical juncture.
And let me make one more point about food. We have to teach consumers about what food is and how it's made. So if you want a red, bright, shiny, perfect apple, that means we throw a lot of apples away that aren't that. And we might even wax that apple so that it looks bright and shiny. And we might put it in storage and put nitrogen on it. If you're okay eating one that doesn't look as perfectly round, then that's a different story. So what we're seeing is consumers want both, but they don't understand what comes with it. So I think a lot of what we do, and I think what ConAgra is so great at, is being transparent about how is food made and how does it come to you.
So true.
Amen.
In our industry, a lot of people, will demand for organic beef or whatever. But a lot of times they don't realize what that means is that these animals were never really treated properly. So they're probably not getting the best beef, most likely.
Question.
So this is a great panel because of the diversity of the data, but also the different scales at which you're dealing with data. And you alluded to sort of the human factor in terms of curating data. I wonder if you could maybe separately comment on sort of what approach you've taken to these data streams and sort of using NLP and human curation in the process.
So for us, when we take a call from a consumer, we have up to 40 different agents taking calls from hundreds of thousands of people every single year. So the variety of data that we get in our consumer verbatim is all over the place. So for us, text analysis is extremely hard because you have to predict the emotion involved in a consumer contacting you, misspellings, misunderstanding of what they're saying. So for us, reading through the information is actually probably far easier than doing text analysis. It takes more time, but then you have people who can interpret the information better because you have people taking information stories from consumers. It's not just a data set where it's, black and white. There's a lot of gray involved in that information that we deal with every single day. We haven't got there. The data tools are extremely expensive, and when you're in industry, you have to go with, what you have. We've tried some text analysis internally with our statisticians team, and it's been very eye-opening that it's really hard to do when you actually try that with consumer verbatim because you have people emailing you, you have people who don't spell words right. So when you text analysis, you have to assume what misspellings are going to come through to be able to get a good data set to pull through. So it's hard.
So we've done some of this work with Jim's team, and where we did NLP, and then we're starting to add on some AI. And again, we had to go back and create a taxonomy. And so as an example that I always like to use is the green bean. In some data sets, it's green bean. Other times it's legume. Sometimes it's bean, comma, green. And sometimes it's 05247. It all means green bean. And so one, getting a good taxonomy, and then every time you add a data set, you need to map it to said taxonomy, and then you have to understand the context in which that word is coming through. And so we're teaching the systems to do that. However, that human context is so important that if there's an oil shortage or gas shortage somewhere, or the port of Houston or Miami is now not functional, that's a piece of context to know there's a disruption in green beans, but it's because there's been a natural disaster that isn't allowing for transportation to happen. Or perhaps there was a bombing somewhere and that's in a politically sensitive area. They've just shut down all the borders. So for instance, in Syria several years, almost 5 or 6 ago now, the Minister of Defense was assassinated. And I said to a food company that might have been local, I said, does that matter to you? And most of the people in the room said, what are you talking about? This woman is crazy. Who brought her in? And the spice guy in the back said, yeah, it's a huge problem because I can't get cumin out of Syria now. And all of a sudden the room erupted because they only knew they bought cumin from Greg. They didn't know where he got it from. And because of that assassination, borders were shut down and they couldn't export. And all of a sudden they had to go back and look at all their recipes and see if they could actually produce food. So that human context that seems irrelevant is really important.
So I'll be completely honest with you, I didn't fully understand the question because I don't know what LP means.
Natural language processing?
NLP, okay, got it, okay. Yeah, probably doesn't quite apply to my situation, but in our situation, a lot of times, one question we do get asked is the type of data that we're collecting, is the type of system that we've made, will it replace pen writers altogether? And the answer is no. Our system can certainly help identify those sick animals, but you still need to have the humans there to be able to pull them out, do the final diagnosis, give them the right treatment, put them back, so.
Okay, so we have time for one more question. And
I'm Raji from Minnesota State, Mankato. My question is for all of you, but especially for Amy. So I wonder if you think about using a blockchain for tracing food contamination. And if so, are you planning to implement it?
So if you haven't read the articles that have sort of been everywhere in the last month, Walmart has initiated a partnership with several other food companies to do blockchain and traceability and trying to identify authentic food and products. So there's a great Forbes article, there's several in IT magazines as well about how they're implementing or starting to implement blockchain to be able to do traceability. There's some other traceback solutions that you could invest in as well. We have a supply chain one that I had one screenshot of to partner companies together. Some of the challenges, and I love Daniel's feedback as well, some of the challenges is this companies don't want to share. They don't want to share their data. And for me to understand udder to butter or boat to throat if we talk lobsters, I need to really understand all the pieces in there. And if we have a problem somewhere, and I know you alluded to the peanut and cumin instance, so there was peanut that ended up in cumin because they needed to boost the color. Well, if we don't understand where everybody's buying cumin from and build that sort of spider web of traceback, it's really hard for us to do anything more than an after-action report. Like, how do we mitigate? So one of the biggest challenges is getting companies that sit within a supply chain to share data with each other.
So I've previously supported our recall team. I was the recall coordinator, so traceability is an extremely important thing. If you can't recall your product or trace your product within hours, you're dead in the water. Regulatory agencies want to have an answer within a couple of hours, and I can tell you that I helped develop some software and trace products for the company so that we went from having to trace products that took over a week of manual analysis of multiple people down to 10 minutes. So being able to have that information at your fingertips is absolutely huge, and it can set you apart in the industry.
And I would say the big food companies get it, and they know how to do it, and they're working on solutions like blockchain. Big companies don't make all our food, right? I'll have to say my favorite salsa is Lisa Salsa. It's on University Avenue. There are 8 people that work there. They don't have solution sets like this, right? So how do we help the small and medium companies as well that are producing huge amounts of foods, or maybe co-packing your favorite spice that goes on the rub for your favorite steak?
Yeah, there's certainly a lot of interest in blockchain, I think, in the livestock industry. Even people are starting to kind of wake up to it just because of this whole traceability. And, I think right now in our industry, I think where we're at is we're still probably struggling with what is traceability exactly before we even get to the, the technical aspect of how you do it. I'm not quite sure where we'll land on that exactly. I think, interestingly enough, earlier this year when Amazon bought out Whole Foods, I think that, those types of things are going to play a lot, pretty heavily into what becomes traceability exactly, because there you have actual entrepreneurs thinking through what does a customer really want. So I'm actually interested in watching to see what happens there, because that will help define what that really is.
Well, thank you, Vishal, Amy, Danielle. Thank you so much. Let's give them a round of applause. And thank you for listening.
Thank you all very much. So we have one last panel this afternoon, and that is shortly titled Putting the Smarts in Smart Columbus. So we have a team of people from the Ohio State University here today to talk about their interactions with the Smart Columbus project and also the work they're doing directly related to building up Smart Columbus as a broader entity and project. I'd like to introduce Raghu Mariachu, who is a professor, and he's the interim faculty director of the Translational Data Analytics Institute. And I massacred your last name, so I'm going to let you say it again. Thank you. Machiraju. There we go. Okay, thank you. Anish Arora is a professor also at OSU, and you've heard from Ayaz Hyder today, who had a poster, and he works mainly in public health areas and is also part of the Institute. Thank you.
Hi, good afternoon. We'll try not to keep it too late because we are between now and drinks and dinner, so we'll try to at least make it lively too. And we're all from Columbus, the three of us. Actually, there is also David Monjos. There are four of us from the Ohio State University. And we are in different departments. I'm in computer science and biomedical informatics. Ayaz is in College of Public Health. Anish is from computer science. David and myself, actually all of us are part of Translational Data Analytics Institute at Ohio State. So it's a pretty large investment in data analytics across the campus. So there's a big aspect of translation. And that's essentially what you would see here. I mean, Anish and I speak very different languages. Ayaz speaks very, very different language, but we all work together. So we've been tossing and turning some ideas around lately. And a lot of the ideas, have a driving function in terms of the Smart Columbus project that Anish has been very involved with. He's going to talk a lot more about Smart Columbus. And Ayaz is then going to pick up some points about social determinants. Yes, you can build technologies, you can deploy them, but they have to solve something. They have to help folks overcome some problems, and that's what Ayaz is going to talk about. And then in the end, I would actually close the session, and then once I'm done, then we'll throw the floor open for all kinds of questions.
Great. So we're a tag team, and this is a story in 3 acts. I'm Act 1. I guess I drew the short straw because I'm serving on this core team for Smart Columbus. But the overall point I would like to make to you folks is that we have this effort which has an underlying architecture. And this architecture is conceptualized as a way of providing a diverse set of community services for smart city needs. And the architecture is very appealing, and I'd like to communicate to you how it works. But does that architecture, and this is the second part of my discussion, actually serve for all the communities that we aspire to reach? In particular, we are interested in this panel in underserved communities. And so I'd like to pick on what the gaps in the architecture are for meeting underserved community needs. And really, my colleagues will tell most of the story about the gaps. So to begin at the beginning, we had this interesting investment in Columbus last year where the federal government gave us a modest-sized grant, and Vulcan supported it by allowing for various electrification activities. But most interesting in this effort was how the local community got together to see how they could contribute to it. And I think that's what made Columbus somewhat attractive to the Department of Transportation. So Ohio State is a substantial contributor to this effort, and we are very interested in the ways in which research will transition, and translational data is part of that transition. So what is Smart Columbus? Well, at a first order of approximation, Smart Columbus is seen as a bunch of interesting projects for very diverse neighborhoods. And so, the effort is scoped up in 4 different neighborhoods, communities, if you will. And I'll begin with sort of the easy ones, the ones that are more ready for delivery. So talking about these 3 districts, here's a smattering, and I'll try and do this somewhat quickly, of the projects that should be on the ground this year, within the next 2 years, that people should be able to use. So in a commercial district, in a shopping area, where there's a number of employees who are sort of struggling to make it to work, the idea is, can there be smart hubs? And from smart hubs, can you have autonomous vehicles pick them up? And by the way, when employees are not using those autonomous vehicles, that they can be used to help cart children and shoppers around. So by the way, what is the concept of a smart hub? Can that be connected to a fiber optic system which is monitoring buses traveling down core highways and making sure that those buses travel on time without getting delayed? That's part of this effort. Now, if you shift gears to a downtown set of projects, there the question is, can we manage deliveries in such a way that people are not delayed? So if we have information about utilization patterns, more or less in real time, can we advise delivery trucks that they can drop off for restaurants and other places in downtown where they serve without holding up traffic? Can we make parking more intelligent so people are aware where there is availability and what's going to cost them, and this can be updated dynamically in a way that's user-friendly? Now, from a logistics perspective, there are a number of efforts which are about making platooning more efficient. So part of Columbus, we are a big distribution center, so you'd like these platoons to be able to reduce the energy consumption by sort of teaming up, by knowing where they can rest and what routes they can take without getting into areas where they get stuck. So we routinely have accidents because there's construction going on, people are not aware, and so trucks adjust their routes and get into trouble. So maybe those services can be made more efficient. And so all of these are concepts which at some level are ready for realization and in various stages of rollout. And we advise in some of these efforts. Now, the residential projects are a little bit more edgy, more challenging. And this is a part of town that's called Linden. Linden is a low-income part of town. This is about 25 or so square kilometers. You have about 35,000 or so people who are low income. They're living in an area where there is declining home ownership, and that comes with a bunch of crime issues. It comes with mobility issues. These folks have difficulty getting to work. They have to sometimes use multiple transports. And so that's making this part of town somewhat challenging to be a thriving part of town. So can you make it safer for them? You have grocery stores which are pulling out because it's not economically viable to be there. So there are food desert issues. And of course, there are related drug issues, which we'll talk more about in this panel. But perhaps the thing that made Linden very notable nationally was the fact that it has the highest infant mortality in the country. And this is over this decade. So it's kind of shocking that in a thriving city, you have a problem as acute as this one. So what does it take to realize community services for all of these projects? And the conceptualization of Smart Columbus is relatively simple, that if you can combine the availability of data acquired, accessed through IoT, you can build apps which can deliver these services. So really, Smart Columbus really is about applications having solved the access and the data availability problem. Perhaps I got ahead of myself. So let me just spell out the specific projects going out in Linden on this slide. So the image on the top left is about how would you address safety in Linden. So could we use smart street lights as a way of reducing the cost of lighting in Linden? And if we reduce the cost of lighting Linden, we can cover more of Linden with smart street lights. By the way, with smart street lights, you can deliver Wi-Fi. And with Wi-Fi, you can deliver the access to apps that folks in Linden might need. So that's project one. Project two says, there are folks who have mobility, who have cognitive disabilities. How can you support their access to transportation through an application? So this app has been tested in certain diverse communities and is being tried out in Linden as well. The third one is about instrumenting buses and other city utility vehicles with sensors so that you can be aware of where pedestrians are. And so you can have early warning so that accidents can be avoided. This is a partnership with Mobileye, which provides this kind of sensors, and they're being instrumented on our Kota buses. The next project is the ability to do payment in a convenient way. So here's a user base which might like to use a combination of buses, but also perhaps shared transport, if shared transport becomes economical. And hey, even if you need to use a bike to get to the smart hub, that should be possible. Can you pay for all these in an easy way? So what is a common payment system that someone who's on a cash-based economy can use is to be delivered through this project. So there are apps for doing multimodal trip planning, and as I mentioned earlier, the Smart Mobility Hub will be part of Linden so that folks can get information about what time buses are coming in a very accurate way through these hubs. So the story about how these community services are delivered is by solving this triumvirate about data, IoT, and apps. And Columbus has, already about 500 data sets which are being offered for various users today. So how do you convert those data sets so that they are available in this framework? And so the technical part of the offering is to think about an integrated data environment as the core of Smart Columbus. And this becomes a bunch of requirements which are sometimes conflicting. So the data is very diverse. It has to be available in a form that is accessible to users. So in fact, the data is viewed as the primary asset that the city is offering. And what you need to do with this asset is to have a very good governance framework. So governance becomes a key issue. What data is shareable with whom, at what quality, and is this data being offered in a way that ensures privacy of the data and is suitable for analysis? Of course, the main thing you would like to do is to have easy integration of apps. And once easy integration is enabled, perhaps this becomes a cost-effective way of creating new services. So that list of requirements is actually quite large. And the city is working through some particularly tricky issues with what can be public and what can be not made public. And that showed up in one of the earlier panels, I think the machine learning panel, where this challenge between open and closed is really a tricky one, especially because the Department of Transport's mandate is to be able to largely have an open data system, typically built with open source tools. And the reason the Department of Transportation wants this is because if you build a system in this way, it can be replicated to other cities. And that's one of the key goals here. So is this data going to be secure? But more importantly, is this data not going to do harm? So the city thinks of itself as delivering critical services, and if this data can be leveraged to compromise the services, now harm has become a real possibility. So they are very concerned about the distinction between closed and open data and protecting the city from denial of service attacks. So Seattle, for example, had a situation where public requests created so much workload for the city that the city could not manage those requests and had to slow down its operations for a while. So how does Columbus protect itself from that kind of denial of service, but also from liability of various scales? One more challenge for us is that this system is not being built for Columbus alone. It's being built for the city of Dublin. It's being built for other townships around us, but also the Mid-Ohio area. So the thinking is that this is going to be not just city scale, but regional scale. So it'll have to address concerns that apply to these other districts. And as a result of that, should be more likely to be replicated than some of the systems which have been built previously. So in many ways, Columbus is not the new kid on the block. We are probably the 10th kid on the block. And we've tried to learn from the other 9 cities which have done this well in the US and internationally to see what might be a replicable framework for us. But the last goal for us is perhaps the main substance of this discussion, which is the bit about fair access. So can we build a system which can solve data access in a way that is fair, particularly for the underserved? So perhaps I'll very briefly talk about the technical elements of what exists. So of course, it is more than a data lake. There needs to be a whole data management system which incorporates the creation of metadata, the cataloging and searchability of metadata, the incorporation of business analytics, adding visualization support, etc. And this comprises of an open data portal, which at the moment has been instrumented with an open source framework called CCAN. So we have a CCAN framework, but a lot of the thinking, which I'm not trying to detail at much length, has been about what is the data governance process, what is the API creation process. It's a dynamic API system. And of course, what is the publishing process to begin with? How do you clean, how do you make sure data is going to be at a level where it's more likely to be useful? So the fair question, the fairness of data, brings us to these wicked problems which places like Linden bring up. And the question of how do you deal with the food desert issue? How do you deal with the opioid crisis? And how do you deal with infant mortality? And these are things that really Ayaz and will set up the scope of the problem, and Raghu will tell you about aspects of how we will handle this in data. But the one story I would like to tell is, even from a technical perspective, solving the access problem in a fair way is difficult. So as somebody who builds sensor networks, wireless mesh networks, here is a challenge that Linden has posed for us. So the map on the left is a map which talks about where fiber exists in the city. And Columbus is very proud of how much fiber we have. But if you look at the actual prevalence of fiber compared to where you want to deploy sensors, for example, where you want to deploy smart street lights, it turns out that if in Linden we tried to put smart street lights, we would probably cover less than 10% of Linden. So the access to something like fiber is limited, not only in Columbus, but I would argue even in larger cities. Now, one might argue that we have all these public Wi-Fi infrastructures coming online. Shouldn't that solve the problem? And so the image on the right is taken from New York City, where we are doing some projects in sensing in the city. And New York City, if you look at that graph, you see those blue spots, which are all Linksys kiosks. So a Linksys kiosk is connected to fiber, and anywhere there is a Linksys kiosk, you should be within 150 meters of that, you should have Wi-Fi access. So today there's like 2,000 or 3,000 Linksys kiosks. Link NYC kiosks, I misspoke. And in a few years, there'll be 7,500 Link NYC kiosks. Shouldn't that solve the problem? Well, it turns out in Manhattan, about 20% of Manhattan will be covered. And in New York City, about 3% of New York City will get covered. So even in a place as advanced as New York City, Wi-Fi, let alone fiber, will give you access to the sensors that you want to deploy. Yeah. So we need a low-cost way of giving access to sensors, of giving access to people. And if you go back to Linden, it turns out the utilization by folks in Linden of data is actually quite low. And the reasons for this are complicated. Perhaps the affordability is low, perhaps there's some self-selection to not using these services. And yet we want to deliver to these folks apps which might help in their quality of life. So how does one make this access low cost? And that raises the question of what is a sustainable model of delivery of low cost data? Now it turns out cities like Columbus are very motivated to solve this problem. They're willing to put up resources for this as long as there is a good answer to sustainability. So the challenge we have is the city doesn't want to run the service. It's willing to put up resources to create the service as long as there is a way of operating this at low cost. And so that too has to be a discovery from projects like ours. So that was the access challenge, but I'll turn the floor to Ayaz to describe the really hard and, in most cases, wicked problems.
All right, great. Thank you so much for the opportunity to speak in front of all of you. What I'm going to do is set up the problem and give you a different aspect of what Anish spoke about. So I'm going to describe the public health challenges that we're facing from an urban and a rural context. Especially in the Midwest, the rural context is something I've come to appreciate is really important. And I'm going to give you specific examples from infant mortality, the opioid epidemic, and food insecurity that are affecting Columbus specifically. And then I'm going to go through some use cases that are going to illustrate to you why this is a really hard problem and why is it that we need to break down the silos and maybe change the tenure process. I vote for that. In addressing these problems, in tackling them head on through team science approaches and through the kinds of spoke and planning grants and everything that the Midwest Big Data Hub has to offer. So infant mortality, I want to give you some definitions because all of you may know what it means or you may not. So infant mortality is the death, is when a death occurs before the first birthday of the child. And so if any of you have children or know those who have children, you can understand how devastating that might be. And preterm birth is one of the leading causes of infant mortality. The map that you see is a hotspot analysis that was done by David Norris at the Kirwan Institute. And don't have a pointer, or maybe I do. That's Linden right there. So that hotspot right there is Linden. That's Ohio State University right there. So you can get an idea of why it is a problem. So we know where the problems are, and that's why Linden was targeted. We also know what we need to do to be able to address infant mortality. Since preterm birth is one of the primary causes of infant mortality, we know that we have to address preterm birth. And the way we're going, the way that epidemiologists and public health researchers have shown us how to address it is through providing adequate prenatal care. Now, saying adequate prenatal care, and you'll see this theme throughout this presentation, is nice. Adequate prenatal care. Okay, just show up at the doctor on time. But what you don't realize is that the challenges that some of these vulnerable populations face. So a woman may have multiple children in tow. She may be juggling 2 or 3 jobs at the same time while being pregnant in the 3rd trimester of her pregnancy in order to maintain Medicaid eligibility. And she has to get to her prenatal care on time. She may be at a high risk of pregnancy, meaning she needs more frequent prenatal care visits than a normal pregnancy of a mom who has a 6-figure salary and has maternity leave coming up, and lives in a nice house. So the challenges that are faced in these communities go beyond just saying they need adequate prenatal care. It's to consider all of their circumstances, the intersection of their entire life and their lived experience up to that point during that pregnancy. So that's infant mortality. Food insecurity. Food insecurity is defined by the USDA as household level economic and social condition of limited or uncertain access to adequate food. And so in Franklin County, 16%, with a range of up to maximum of 20% of census of zip codes and census tracts are food insecure. This means that they're having to choose between paying their rent and for their medication or food. And most people will pay for their food where the adults will go hungry so that the children can eat. That's up to 20% of households in a neighborhood. And you can see Linden right there that I've highlighted. So addressing food insecurity means providing access, availability, and affordability of healthy food. And as we just learned in the earlier presentation, how important food is. It's not something that we can live without except for maybe a few days if you're an adult. And so access here means access to food that you are able to afford, food that you're able to access through multiple modes of transportation, food that you really, that is appropriate for your family. So if you're a family with children, you have to buy that kind of food. If you're a family taking care of multi-generation families with other adults, and you have other needs. If you have dietary restrictions, if you're allergic, these are all things that do not pick what allergic conditions, for example, they don't pick whether you're rich or poor. Asthma is one of those examples. So it doesn't care whether you're rich or poor. If you have an allergic through some genetic condition, you're gonna have those allergies. So that's food insecurity. The last problem is the opioid epidemic. And so overdoses due to the opioid epidemic may be fatal or non-fatal. And what you're seeing on the map is the distribution of I believe it's overdose death rate at the county level. And what you see is that there is a pattern and there are these disparities throughout Ohio. Ohio has one of the highest overdose death rates in the United States. And this is something that plays into the politics. It plays into a lot of different things that are being done in Ohio. Some of the barriers to treatment here include access, once again, to transportation, through the lack of insurance, or through the complex health conditions, such as mental conditions, that an individual may have. And I'll walk you through an example of this later on. So why do we need community services for all? I mean, why don't we just deliver these services to those who really, really need it and ignore the rest? Or why don't we just target them to Linden only and nowhere else? You know, why do we need to address this for all? So we have the All of Us Precision Medicine Initiative. It's for everybody, right? It's to address the population level health. It's not to address individuals. So here's an example of why from infant mortality, where you can see that the infant mortality rate is 15.1 among African American mothers in Ohio. That is actually higher than what it is in Syria right now. That is approximately what it is in Panama, in Paraguay. I had a whole list of, in Brazil, in Jordan. It used to be almost as high as what it was in the West Bank and Gaza Strip. And that's in Ohio. That's in Ohio that we're seeing these disparities. So we do need to address this. We do need to provide solutions for all. Here's the infographic that was developed by the food mapping team at Ohio State University, and there's a lot of information on there, but I just want to point your attention to a few of the statistics. So the one is the average time that it takes for someone to purchase food, about 18 and a half minutes. This was a survey done of 33 people, so you can counter that if you like. But in general, this is what you'll find in these types of vulnerable communities. The other thing that I want to point you to is the graph, is the bar chart up here, so the pie chart showing that 25 and then 21.9. So just under half of the population is food insecure, meaning they have to choose between food and rent. The other interesting information is up here. If you look at the choosing. So these individuals were asked, what did you choose? When did you, how frequently did you have to choose between paying for medicine or paying for food? Paying for your rent or paying for food? And up to 36% said they had to choose between paying rent and paying for food. So what do you think they chose? They probably paid their rent, right? And they went hungry. So this is a real challenge. This is a real problem that affects, and the area, the zip code that I chose to pull this information from is covering most of Linden, the South Linden area as well. So these are the challenges. Here's another map showing you where, and this will lead into what Raghu will talk about, but this is showing you an area of Ohio, the Appalachia region especially, where the opioid overdose rate is very high, but look at where the disparities are in terms of data access as well. So I just pulled some numbers from the state of Ohio data on this, and you can see that the rate of opioid overdose is higher in the Appalachia states, but so is the disparity in terms of data access. So what's the problem? Many times that's actually the problem. We don't know what the problem is. What's the question that we're trying to address, given all the amazing data and machine learning and tools and everything that's really nice that everybody here does and gets published? Here's the real problem. So imagine an individual, and I'll walk you through this, but imagine an individual comes into the ER because they've had an overdose. They maybe have been given a naloxone or Narcan where they were picked up and they were transported to the emergency department, where the physician tells them, okay, we've given you Narcan this time, but we're not going to give it to you again because you keep coming back. The same individual keeps coming back and back again because they know there is Narcan available. But this person, in order to get treatment, they have to, they're contacted by a social worker or a community health worker who might say, okay, well, you need to address this in your life in order to get treatment. But there are multiple barriers that person might face. They might have multiple jobs that they have to worry about. Therefore, they have multiple schedules to worry about. They might have to get that permission from their employer. They might have childcare needs. They might have to make sure that their children are going to be picked up after school so they can make it to their next appointment. And then if they complete their treatment, that's great. But if they don't, they are at risk for another overdose. And so the cycle continues. And there are different places, places on that diagram that you can identify where data is being collected, where data may be analyzed, where data may be informing different stakeholders who are part of the solution over here. So there are disparities that exist in terms of data connectivity and access, but there's also issues in terms of following up, and especially when you have complex patients. So this is where the health information, but also many other types of data come into play. Here's the second last slide that I have, and this is an example from the food systems. And so there are multiple stakeholders, as we can all see from the previous presentation, but there is limited connectivity except for supply chain. So we saw the work that was being done and how those supply chains are connected, but there's very little that's done in connecting those supply chains that make business sense, that make preparedness sense to the health outcomes. And so what that leads to is that there's a lack of optimization in how the food environment can help address obesity, but not just obesity, many other types of food-related, food insecurity-related problems that vulnerable populations are facing. And then there's a lack of coordination between data-related activities. So while you might have that IoT person or that IoT startup doing a great job at getting their venture capital in place, what does that do for the actual people that they're trying to address, or that who could benefit, but they can't because they don't have a fridge in their house to begin with? So what people need are actually fridges, not necessarily sensors to tell them how much milk they need. So what I want to leave you with is the question, and I answer it for myself, but maybe you arrive at a different question, is Smart Columbus the answer to providing community services for all? I wasn't part of Smart Columbus. I'm in the School of Public Health. I'm not coming from a computer science background, so I just found out what an IDE is today. But from where I sit, from what I see, Smart Columbus is not the answer, but and it can be a part of the solution if we do break down those silos and figure out how to work together. So the question that I'm going to pose is that because do data analytic, sorry, just to back that up. The reason I say no is because of the social ecological model that I've put up there. These are the different levels of organization at which decisions are being made by different entities, and this is a model that's used in public health to address public health policy, but also how to make decisions. And so when decisions are being made at these different levels and data is being collected at these different levels and there is a lack of coordination, then we run into problems. And I'll end by asking the question, do data analytics, data-enabled technologies, and quote-unquote big data tools fit into this picture? If so, then how and why? Thank you very much.
So I'm going to talk a little bit about the data, and I'm going to make it about data inequality and also about the whole system not serving different populations. So to add specificity to the description, I'm going to talk about the opioid epidemic that's ravaging Ohio and the Midwest. Aya's already talked about it, and Anish talked about Smart Columbus, and as Anish said, it's not just about Columbus. It's Columbus and the environs of Columbus that Smart City is going to address. So we'll use the opioid epidemic to drive home some points. So if you just go even beyond Columbus, okay, the situation is pretty grim. Even if you look at a county like Fairfield County, which is not far from the center of Columbus, it has its issues. I mean, there are resources, but the resources are not enough. And they have, certain efforts, like they received a Department of Justice grant where they collected quite a bit of data, and they have done some analysis, but how much more can they do? Do they hook up to the epicenter syndromic, software systems. Maybe, maybe not. So it depends, depends on several factors, including resources. So those are the kind of issues we are, addressing or touching upon right now. So it's about how much underserving is going on. So as Anish said, even in a city like Columbus, which is fairly well-to-do, you have the Lindens. So almost every community is like Linden in a certain way. So being underserved has a certain kind of flavor. Okay. And if you go way beyond Columbus, as I'm using the same plot same map that I has used, it's really pretty grim actually. And many of these counties are pretty underserved. But once again, the big cities like Cincinnati, Cleveland, I mean, they are doing well to an extent with, along with the Lindens that they all have. Now, if you go down south, all the way, to the border with Kentucky, Portsmouth, we have, Ohio State has a presence there, Scioto County, Pike County. The real issue is, quite simple and basic. I just talked about, this scenario, which could become a workflow that, perhaps you can throw cyber infrastructure, all kinds of data comments, do whatever you want, okay, and maybe address it. But the basic issue is it's essentially, the barriers come from lack of communication. They do not even have cell phone reception. It's that critical. So essentially, this is the main impediment, and it basically does not allow the community health worker to help the addict, the unfortunate person. So, and the other big problem is data is really siloed everywhere, and this is not just for Pike County or Scioto County, pretty much every, many agencies across the state and elsewhere. So this is, by the way, a great book. So what's happening is the inequality that actually reinforces the underserving nature of the problem. So and there's inequality in access, connectivity, computing, technical know-how, and so on and so forth. Okay, I'm not an economist. I'm not a social scientist. These are some of the points that I actually learned from others. Is technology a solution? And that's what we're going to look quickly look at. So because you do not do not have even internet connectivity, because data is siloed, the community health worker cannot help the addict, that unfortunate person. So she cannot look at treatment alternatives, find recovery, deserts, recovery resources. So all of these issues become quite profound. And what about somebody who has who might have more resources, like a public health administrator? He or she could be in a better situation. So here we are looking at the population in general, not looking at individual person as we did before. So here you could again set up an entire set of resources, and you could build all these different stages. And sometimes you do need resources like the epicenter, data analytics, syndromic platform. That takes not everybody can do it, but let's say if they can do it, it's still not enough. You probably need more tools that allow for visualization and analysis. And there's a lot of issues with privacy and so on and so forth. The other panels also talked about this. So in general, there's just too much going on for quite a few administrative centers. And again, they would not be able to answer many of these questions. Study the deaths, look at opioid prescriptions in the county and elsewhere, and so on and so forth. I think it's more insidious than that because there are gaps in the data. There's a lot of variations in the data, and even asking simple questions like prevalence of chronic pain, how does it relate to rates of reduce? Okay, so I mean even trying to make that correlation is not easy. Therefore, you do need data analytic techniques, and so on and so forth. I mean I have a list of these questions, and they all come from actually a wonderful publication in Kentucky. So I attribute my source there, and there are different data variations too. What exactly are you talking about? Are you talking about people, where they live, or essentially the non-residents and residents? So there are lots of nuances which can really confound the public administrators too. So in a sense, there are so many questions. There are so many I guess situations or scenarios. Maybe the very first thing you have to do is engage with the community. So we've been talking about that with our colleagues in public health. How do you engage with the community? How do you basically use those scenarios to convert into workflows? How do you basically design a cyber infrastructure, big data tools, and then how do you actually go back to the community and then perhaps test these tools? So we've been also talking to Rahit Ghani about some of these ideas, and the whole idea, the whole intent is to collect, build, and train, and essentially have a basic minimum viable product. Use an entrepreneurial approach to build something like this. So then, of course, it's not just agility of the work, methods or workflows, but could you actually talk about different kinds of data, right? You do have a lot of retrospective or existing data, but that's not usually enough. There's a lot of real-time information that needs to come in, and that's really important for timeliness. So we certainly think that open systems are the way to go, using wireless meshes that Anish has been deploying in Linden. We are building a data commons right now, and then we are building it on top of systems that Ohio Department of Health already has, the syndromic surveillance systems. And of course, we have a lot of tools, data analytic tools that are open source that could be brought to bear upon this problem. But then again, a lot of folks use proprietary tools, so how do you actually connect with them? So the notion is that could you actually build open API tools? So we're certainly working with the city of Columbus and working with the Columbus Integrated Data Exchange. There's also the Columbus Sandbox, which comes from the Collaboratory, and one of the major players is the Translational Data Analytics Institute at OSU. So this is essentially what I have to say. And if you have any questions for any three of us, we're a little bit over time, but I guess we can still perhaps ask questions.
So I have a question. Thank you very much for that. So, I've come to visit. I've had some conversations, had the opportunity to talk to some of the people in the city of Columbus, and we heard earlier about opportunities for potentially replicating the process of building out smart community sorts of infrastructures in different cities and how that's working or not working, and some of that work. So, there's a couple levels of city. We've got big things happening in Chicago and New York, but we see even in New York, there's huge limitations. What are the processes that are working for the interactions between the NGOs and the chief data officers and the universities and academic researchers and other communities that are trying to solve some of these problems by coming together? How is that working? What are the barriers you maybe can tell us about? And I know we don't have too much time, but I just thought I'd ask that.
It's a great question. Yes, I think the strength of the Columbus effort was largely how the community had come together. And I'm not exactly aware of what led to it, but clearly the NGOs and the for-profit corporations in Columbus, but also those that the city tried to engage nationally, saw there was a benefit of participating. So I forget whether I mentioned, but we've raised these partnerships have contributed in kind or in real supports about $300 or $400 million, and the goal is to reach $1 billion in a year or so. So one point to be taken away is that the companies that are contributing do think that this will translate into benefits for them. That is very clear. These companies are providing communications, they're providing sensors, they are providing analytics, and perhaps they see that this is a way of improving their own internal operations, but also producing products which their customers can use, which is beneficial to them. Now, why the not-for-profits have engaged, I hope some of my colleagues can speak to that. But clearly, we do see that they are willing to be the guinea pigs in trying out these apps because they think that these apps actually are material for their user base. So in some sense, I think the marketing within the city of what the system can do, of the innovation that can result by making this open, by making integration simple, by making APIs accessible to all, and the barrier to entry as being very low, it has seemed to connect with the community.
I have a question. I saw the term community engagement in your slides, and I wonder how you engage the community and what you consider the community in that respect. Who do you talk to when you collect data?
Thank you. So community, the way we've defined it is that it includes everybody who is part of the problem, but also part of the solution. So at one level, you have individuals who are suffering, whether they're pregnant women who can't access, or they are people dealing with substance abuse problems. At another level, it's the physicians and the clinicians and the public health officials who are interfacing with those individuals on the front lines on a daily basis. At another level, there are those policy officials, government leaders who have a say in what, for example, naloxone access. How do you facilitate that? How do you make it more widely available? How, those who control the funding and the purses for distributing that. So there's different levels of, like I showed in the social ecological model, there's different levels of community, and our aim is to engage with all of them.
Curious how you can do that with all these levels with a cell phone app when there is no cell phone service.
Right. So the cell phone app is a solution that's going to address a particular community. There are other solutions that will work for other stakeholders. For example, Epicenter is the syndromic surveillance system that Ohio Department of Health uses. Epicenter. So it's a syndromic surveillance system that picks up anomalies in space and time for things that are non-random. Things that are like a spike drug that leads to multiple overdoses in an area where typically there aren't that many at that time. So that is a surveillance system that isn't available or isn't utilized as best as it could be among rural communities where one epidemiologist is dealing with 5-6 counties at a time. And so developing an app is not necessarily the solution there. There it might be data connectivity between different systems and data visualization tools that might work differently. So and community engagement is at the beginning, but it's also throughout the whole process, and it's also at the end as a type of validation that did we do something that you will actually use.
What I would add to that is the one experiment we are trying to do about the question about when you don't have cell phone, what's a cell phone app? Sure. So the experiment we are trying is to deploy low-cost wireless meshes. It turns out, community wireless mesh networks have been quite successful in different parts of the world. In Catalonia, there's a network which provides shared access to the internet to about 300,000 people. In Bogota, there's a big network. So these systems are open source, they work. What they don't work for is for providing Netflix to everyone. But if you want to provide an app which has a modest data requirement across a mesh network, that problem is essentially a solved problem. And so the question is, in a place like Pike County or in a place like Linden, can we deploy a Wi-Fi or some other wireless technology mesh where your phone can leverage that mesh instead of using cellular data? So that's the approach we are trying.
I think you it must be dead. I think you may have just answered this question, but I noticed when you gave your presentation, you talked a lot about the fiber infrastructure in Columbus, but you just mentioned wireless mesh and cell. Is the intention it sounds like you're going to be looking at multiple ways of getting information to and from people, but is the backbone going to be an expanded fiber network?
So you're right. This is going to be a heterogeneous system. And over time, one would imagine that many other 5G alternatives are going to be there, and some of them are going to be affordable. At the moment, that marketplace is very confusing, where both unlicensed spectrum option exists, like LoRa technologies or Sigfox. There's licensed technology options in the form of NB-IoT, but also low latency 5G networks coming. But at the end of it, there is going to be an infrastructure network, and that infrastructure network is going to be mostly fiber. Yeah? So there will be a few places where you could have high rate cellular comms, but most of it, in the context of something like Smart Columbus, will be fiber.
So in Lincoln, Nebraska, where I live, they're laying fiber everywhere, and so I'm painfully aware of the amount of time and investment that requires. Is that, I guess I'm not sure, I'm not a domain expert. All these other cities, the other 9 or 10 cities that you mentioned, are they relying on a fiber backbone as well?
I don't know the answer to that. My assumption would be yes. That would be my assumption, but I don't definitively know the answer. So the complementary point is there are some cities or towns which are more progressive than others, like Chattanooga has got gig networks to every home. So in a place like Chattanooga, because of that investment, perhaps you can go directly to using this high-speed link for everyone. But the question is, what becomes replicable? And for the replicability, it's going to be a mix of technologies. But what we are most concerned about is having a low-cost edge as being available.